Let's get right into it. Number 6, the grandfather paradox. Have you ever fantasized about time travel? Maybe you'd go back to give your younger self some winning lottery numbers, or to stop a truly embarrassing haircut. It all seems pretty straightforward until you run into a time travel paradox so mind-bending it threatens the very fabric of reality. We're not talking about accidentally stepping on a butterfly, we're talking about preventing your own existence. The grandfather paradox is a thought experiment that asks a simple but impossible question. What happens if you go back in time and prevent your grandfather from ever meeting your grandmother? You'd be stopping your own birth, which means you could never go back in time in the first place. You create a logical loop, a cosmic traffic jam, where the cause, you traveling back, is destroyed by the effect, your grandfather not meeting your grandmother. It's a classic chicken and egg problem, but with a paradox so extreme it implies that time travel might be impossible in our universe. Imagine you're trying to delete a file on your computer, but what if that file is the software that allows you to delete files? You can't delete it without the software, but the software is the very thing you're trying to delete. The system would just freeze up, trapped in an impossible contradiction. That's the grandfather paradox on a cosmic scale. The universe hits a logical brick wall and refuses to budge. This paradox suggests something profound about our universe. Either time travel to the past is an absolute no-go, or the rules of reality are so complex that the universe finds a way around the problem. Maybe it's a multiverse where you create a new timeline, or maybe it's just a cosmic access denied error message. Number 5. Olbers Paradox. Look up at the night sky. What do you see? A few thousand stars, maybe the moon, and a whole lot of inky blackness. It seems normal, but for centuries, astronomers and philosophers have asked a simple, unsettling question. If the universe is infinite and full of stars, why isn't the entire night sky blazing with light? This is Olbers' paradox, and it goes like this. In an infinite, static, and timeless universe, every line of sight should eventually end on the surface of a star. If that's the case, the night sky shouldn't be dark at all. It should be a blinding, uniform sheet of light, like standing in the middle of a cosmic disco ball. The fact that we see a dark sky means one of the core assumptions must be wrong. Imagine standing in a gigantic, never-ending forest. No matter where you look, your line of sight will eventually hit a tree trunk. The entire field of view would be filled with nothing but wood. The universe, according to the paradox, should be like that forest, but with stars. The fact that we have these big gaps of blackness is a huge clue that something is up. The solution to Olbers' paradox is one of the pillars of modern cosmology. The universe isn't static or timeless. It's expanding, which stretches light from distant galaxies, making it redder and dimmer, a process we call redshift. And the universe isn't infinitely old. It has a beginning. The darkness of the night sky isn't a sign of emptiness. It's a sign of a dynamic, evolving, and very, very big universe. Number 4. The paradox of the ship of Theseus. You get a classic car, a rusty old thing that's seen better days. You lovingly replace the doors, the engine, the seats, and the tires, one by one, until every single original part is gone. So, is it still the same car? This simple question leads to a philosophical puzzle that has baffled some of the greatest minds for over 2,000 years. This is the ship of Theseus paradox. The original ship on which the hero Theseus sailed was preserved by the Athenians. Over time, as planks rotted, they were replaced with new ones. Eventually, not a single original part remained. The question is the restored ship still the ship of Theseus? The paradox deepens when you take all the discarded original planks and build a new ship. Which of these two is the real ship of Theseus? Think about your own body. Over roughly 7 to 10 years, almost all the cells in your body are replaced. The skin cells you have today are not the same ones you had a decade ago. Your bones, your organs, all of it gets recycled and rebuilt. So, are you the same person you were 10 years ago? The paradox forces us to confront what makes something, or someone, them. Is it the material parts, or something more abstract like a continuous identity or a specific pattern of information? This paradox challenges our fundamental understanding of identity. Is it defined by the sum of its parts, a continuous historical lineage, or something else entirely? Some researchers suggest the identity isn't in the material, but in the pattern or the software that keeps the structure intact. It shows us that reality, even something as simple as identity, is far more complex and paradoxical than it seems. Number 3. The black hole information paradox. What happens to information when it falls into a black hole? The laws of physics say that information can't be truly destroyed. It can be scrambled, twisted, and thrown to the other side of the universe, but it can never just cease to exist. But black holes seem to break this rule, and it's a paradox that has stumped some of the smartest people in the world, including Stephen Hawking. The black hole information paradox is about the ultimate cosmic trash compactor. According to general relativity, anything that crosses the event horizon of a black hole is gone forever. It's absorbed into the singularity, and all its unique information, the specific arrangement of atoms that made up a star or a person, seems to be lost. However, quantum mechanics states that information is conserved. It can't be created or destroyed. These two fundamental theories of physics are in direct conflict. Does the black hole simply destroy information, or is it secretly encoded in a bizarre, unreadable form? Imagine you have a book, you throw it into a fireplace, and it burns to ash. The laws of physics say the information isn't gone. The words are just scrambled into the arrangement of ash, smoke, and heat. In theory, if you had a supercomputer, you could reverse engineer that ash and recreate the book. A black hole, however, is like a fireplace that not only burns the book, but also absorbs all the smoke and ash, leaving absolutely no trace behind. It's a fundamental violation of the cosmic rules of bookkeeping. Stephen Hawking suggested that information might be lost, which sent ripples through the scientific community. Other scientists believe the information isn't lost, but is encoded on the black hole's surface, the event horizon, in a sort of cosmic hologram. The resolution of this paradox could unlock a deeper understanding of how general relativity and quantum mechanics can coexist, or it could prove that one of our most cherished laws of physics is completely wrong. Number 2. Fermi's paradox. We're a tiny speck of dust on a little blue planet in one of hundreds of billions of galaxies. With so many stars and so many planets, it seems mathematically impossible that we're the only intelligent life out there. So, with that in mind, why haven't we heard from them? This is the simple, chilling question behind one of the greatest paradoxes in the universe. Fermi's paradox is named after physicist Enrico Fermi, who, during a lunchtime conversation, famously asked, "Where is everybody?" The argument is straightforward. The Milky Way galaxy is ancient, around 13 billion years old. There has been more than enough time for advanced civilizations to emerge and spread across the galaxy. Given the sheer number of stars, it's highly probable that some have. A civilization capable of interstellar travel could colonize the entire galaxy in a few million years, a blink of an eye in cosmic time. But we have found no evidence of them. No signals, no probes, no megastructures. The silence is deafening. Imagine you're walking along a beach that's supposedly a bustling city, but there's not a single footprint in the sand. You know people should be there, but there's just nothing. It's unsettling. It forces you to wonder if the city is a myth, if everyone's hiding, or if there's some strange reason no one can make it to the beach. The lack of footprints is the paradox. The silence from the stars is the ultimate cosmic head-scratcher. The potential solutions to Fermi's paradox are both fascinating and terrifying. Maybe the great civilizations destroy themselves before they can spread. Maybe advanced life is so rare that we truly are alone. Or maybe, most unsettlingly, there's a great filter, some cosmic barrier that prevents life from progressing past a certain point. It's a paradox that challenges our assumption that we're a part of a bustling cosmic neighborhood and instead suggests a silent and perhaps dangerous void. Number 1. Zeno's paradox of the Achilles and the tortoise. Imagine a race between the fastest runner in the world, Achilles, and a plodding tortoise. To make it fair, the tortoise gets a 10-meter head start. You know who's going to win, right? The runner will obviously win. But what if I told you a simple paradox says the runner will never, ever catch the tortoise? This is Zeno's paradox, a mind-bending puzzle from ancient Greece that challenges our perception of motion. Zeno argued that for Achilles to catch the tortoise, he must first reach the point where the tortoise started. But by the time Achilles gets there, the tortoise will have moved ahead a little bit. So Achilles must then cover that new, smaller distance. And by the time he does, the tortoise has moved again. This goes on forever. Achilles is always covering half the remaining distance to the tortoise, but he can never fully close the gap. This isn't just about Achilles and a tortoise. It's the paradox of infinity. It's like trying to get to a wall by walking half the remaining distance to it over and over. You walk half, then half of what's left, then half of that. You're always getting closer, but mathematically, you'll never actually touch the wall. The paradox shows how our intuitive understanding of motion and space can clash with the strange properties of infinity and mathematics. While we know from experience that Achilles will definitely catch the tortoise, Zeno's paradox isn't a failure of logic. It's a beautiful, elegant, and humbling demonstration of how an infinite number of actions can be completed in a finite amount of time. It reveals that our reality isn't as simple as it seems, and that there are deep mathematical secrets hiding just beneath the surface of everyday motion. It reminds us that sometimes the world works in ways that our brains just aren't designed to process. That's all for today. Subscribe to see more.